Okay, so for our first presentation today, we have Jean Brown from McGill University here to talk about the young women's creak or vocal fry and the perceptions around it.
Thank you. So today I'll be talking about rethinking young women's creak, piecing together production, perception, and social evidence. So this is part of my thesis research. So first, what is creaky voice? Creaky voice is also known as vocal fry. That's how you might have heard it in media. Perceptually, it's sort of like a low, croaking, or crackly, rough quality to the voice. So I have a few excerpts here.
I forget exactly how it goes.
It's Kim Kardashian.
It's me, Sher Khan. I'd like a word with you, if you don't mind.
This is very like Latin culture, I think, Selena. And
left for filming, got back together with Jesse.
So those are examples of vocal fry, and acoustically it really looks like this. So on the left I have modal voice, on the right I have creaky voice, and you can really see that there are these sort of irregular vocal pulses that are in the spectrogram here. It's produced with low F0, tension in the vocal folds, and low transglottal airflow. So, as of the late 2000s, mainstream American media really begins alleging a rise in young women's creak. This is around the 2010s, so you can see some of the headlines here. I'll pull them up. This is on science.org, the New York Times, Vice, Time, and then CBS News. And you can see from this Google Ngrams plot that the use of the term vocal fry really skyrockets around 2010. Whereas it wasn't discussed as much before. And so because of this, creaky voice has been labeled a affectation or a fashion trend, vocal fashion trend of Gen Z and millennial women. And so there have been multiple controversial opinions that have sort of appeared about creaky voice in various podcasts, online op-eds, along with claims that it hurts women's job prospects to use vocal fry. This has also sort of had another side where linguists have sort of highlighted this as a case of linguistic discrimination in which people are criticizing young women's voices as a proxy for direct discrimination against this group. So I ran an acoustic study first on the production of creaky voice to really see if it was the case that young women use creak more often than other social groups. And so here's the data here. So what we can see from this data is really that across all acoustic measures of creaky voice, men seem to be creakier. So this is the blue line here. You'll see that the blue line is always in the direction of more creak for all of these acoustic measures here. So proportion of unreliable pitch tracks, which is sort of a measure of irregular F0. I have H1 minus H2, which is a spectral tilt measure. It's supposed to correlate with glottal opening. CPP, and then H&R 05, which are noise measures here to measure irregularity in the waveform and periodicity. So this sort of doesn't explain now why so many sociolinguistic studies also found the same finding that women are creakier here. So these studies are using impressionistic methods, so they're usually listening to the audio file and visually looking at the spectrogram and identifying what's creaky and what's not. And these do find more creak for women's voices. These are just two of the most well-cited studies here. So I ran a second study to really test this idea that are we more likely to hear creak in women's voices perceptually, right? So this sort of alludes to a production-perception mismatch. So there's sort of two ideas here that might explain this finding. The first is what we call the acoustic bias. So this is just that creak is more noticeable in women's voices because they're typically higher pitched. And so because creak is really produced at a low pitch, you have to drop your modal pitch down a lot, and that's just more noticeable. Alternatively, there's this gender bias where listeners might just be more likely to assume that creak is more common in women's speech, and so they expect it there, they identify it more there. And so my perception study actually found that this wasn't really the case. So I found a reversed acoustic bias here where actually it was low pitch that was really leading people to identify more creak in the stimuli. And for the gender bias, I only found very weak evidence for women being perceived as slightly creakier. And these differences, you can see the orange versus the blue dots here. These differences are very, very small. They're not statistically significant. And so this wouldn't explain really why people are identifying more creak in women's voices. So here I've shown that in the production study across every acoustic measure examined, men's voices are creakier than young women's. And in the perception study, I've shown that perceptual creakiness is really more driven by low F0, and any effects of perceived female gender are really limited at best. And so this shows that the popular narrative here reflects more of a sociocultural bias than empirical reality. And so the question that we sort of started out with, why do women creak so much, should now be shifted to something more along the lines of, well, why do we judge creak the way that we do? What is going on in these women's voices that are making us identify creak differently than for other social groups? And thank you.
Great, thanks so much for your presentation. As I wait for the live stream questions to come in, if there are questions in the room, we can start there.
Yeah, I've got a. Oh, do you want to? Sorry, Keita, do you want to go first? Okay, I'll go. Hi. Have you considered? Are there other sort of vocal characteristics that you might consider looking at or tying into this sort of research that aren't necessarily creaky voice, that are like similarly gendered, like certain accents or certain word choices?
Yeah. I think there's definitely something broader socially that's going on here. So there's like all of these negative opinions that are coming about young women's creak. They're not just about the voice by itself, right? Oftentimes they could be associated to a specific persona that somebody is trying to portray, and that is encompassed in not just vocal fry, but also, word choices. It could be related to pitch also, higher pitch versus lower pitch perception, along with a lot of other sort of socially stigmatized variants in language,
Thanks. I'm guessing you glossed over this. I'm curious what you asked participants about, like when they're identifying creak. What was the question that you asked them to say, like, is this creaky or not?
Yeah, I'll tell you a little bit more about that study, like the stimuli and all of that. So basically what I did for that is I produced utterances of modal voice and then creaky voice myself, and then I gender shifted them so that they were sort of within an ambiguous gender range. And then I took all of that ambiguous gendered stimuli, paired it with a female face and a male face to then try to get at these like social priming effects. And so when I say gender bias, I'm talking about a gendered face bias there. And so what I asked people, I played all of these stimuli, the audio with the faces, and then asked people, how creaky do you think this stimuli is on a scale of 0 to 100? So it was like a visual analog scale. Mm-hmm.
We have a couple questions from the live stream. This one's from Anna Shea. What are the actual measurements you're doing to quantify creak among different populations?
Yeah, so I can go back a few slides here. So I used a number of measures here. These are just the ones that are sort of most used in the linguistic voice quality literature. So I just took a measure of mean F0 since that's easy to quantify there. But the ones that were really related to creak were, first, I took a proportion of unreliable pitch tracks. So here I used Pratt, which is like a voice analysis software. And basically Pratt has a really hard time tracking the pitch when it gets really low and really irregular. So I counted how many times I got undefined or 0 hertz values and used that as a proxy for how irregular it does this sound. And then I also used H1 minus H2. This is a measure of spectral tilt. So it's a difference in amplitude between the first harmonic and the second harmonic, which is supposed to show very low values for creaky voices that are very constricted, so your vocal folds are pressed together, or high values for something like breathy voice where your vocal folds are more spread apart. Then we have CPP, which is cepstral peak prominence. This is a measure of noise across the whole glottal wave, essentially. And then harmonics to noise ratio under 500 hertz. This is really any noise that's going to be going on in these low frequencies, which is typically what creaky voice would cause. So creaky voice is more associated with low frequency noise, whereas something like breathy noise is more related to high frequency noise.
Great, thank you so much. And then one last clarifying question. Can you explain what F0 means?
Oh, F0 is just fundamental frequency, so perceptually it's essentially just pitch.